In this slide, we're going to look at the differences between spermatogenesis and oogenesis. So the total time to produce one gamete in the male is about 74 days. This includes the journey throughout the various parts of the seminiferous tubules and the epididymis. The female is between ages 13 and menopause, or puberty and menopause. So it begins in fetal life with the primordial follicle, but ends in menopause. The occurrence in males is puberty to old age. The number of gametes is similar, but it's only in males where they're actually functional. So there's 4 equal sized sperm, but in females, there's 1 large ovum and 2 to 3 small polar bodies, which don't have much cytoplasm, so they can't be sustained. The number of male gametes, sperm, are over 1 trillion, and it's less than 500 for females. The error rate is 5% for males and 20% for females. And then the supporting cells that surround the gametes, for males, it's a cystenocyte, which is also called a Sertoli cell. And remember from the earlier part of chapter 27 that one big thing the Sertoli cell does is that it's going to protect the sperm antigens from being attacked by the immune system. In the females, there are granulosa cells that make up the follicle, which surround the one oocyte. So this shows our stages of follicle development, which we've talked a little bit about. And the figure that we're going to look at concerning this is shown next on the next slide. But the maturation is going to occur in 2 phases. Phase 1 is that there's a gonadotropin independent preantral phase that involves intrafollicular paracrines. So those are actually hormones secreted from those specific granulosa cells. Then there is an antral phase, which is stimulated by FSH and LH. So there will be an increase of both of these hormones mid-cycle. This is where the dominant follicle is selected. So again, that's why it was actually named follicular stimulating hormone, because that's exactly what it does. It stimulates the follicle. So the primary oocyte then resumes meiosis 1 because it was paused in prophase 1. So the primordial follicle becomes the primary follicle. The primordial follicle, we know now that that is squamous-like cells surrounding the primary oocyte. The ends become cuboidal, the oocyte enlarges, and then the follicle is now called the primary follicle. And the oocyte, it secretes this glycoprotein-rich substance that forms the zona pellucida. One way to think of the zona pellucida is it's almost like it acts like an egg shell. So the egg will then hatch out of the zona pellucida. So it's an inner membrane that has to be kind of invaded by the sperm for fertilization to actually occur. So this image is in your book. This is kind of like the one that we saw earlier. And stage 1 is going to correspond with this primordial follicle. Usually the primordial follicle is located closer to the outer part, the cortex of the ovary. Then number 2 is the primary follicle. So you can see that these cells were kind of squamous looking here. Here they become a little more cuboidal looking. There is the appearance of the zona pellucida. It's kind of like the eggshell around the egg. Number 3 here is the secondary follicle. So it's getting a little bigger. There are multiple layers here of granulosa cells. And then in 4A, right here, we have an early vesicular follicle. It's called this because there is this antrum that starts to form, and we have a different type of cells that are out here. But that is still surrounding the primary oocyte. So it's still arrested or paused in prophase 1. Down here in 4B, we can see a more mature vesicular follicle. So this part up here is 4B, and that is down here, the mature follicle. So this is where that primary oocyte then is going to complete meiosis 1, and now it's a secondary oocyte. There's still that antrum present. We see the zona pellucida around it. Now the ovulation is going to occur, which is a point where the follicle ruptures and ejects this secondary oocyte with a radiating crown. So that's the way I like to remember it. So imagine this is the little princess that has a radiating crown on the outside. So that's going to be important to help you remember those two layers. There's the egg layer, which is the what's going to hatch. That's the zona pellucida here. And then the outermost layer is that radiating crown called the corona radiata. Also helps me to remember that that's one of my favorite beers. So moving on to number 6, we see the leftover follicle cell. So after the follicle has ruptured, it then forms this tissue called the corpus luteum. And the corpus luteum is what's going to produce the progesterones and the estrogens. And if pregnancy does not occur, this corpus luteum will degenerate to form the corpus albicans, which is basically scar tissue that is left over. So let's look at the stages of follicle development now. This kind of reviews what we've kind of talked about now, but the primary follicle becomes that secondary follicle. So it's not too important that you remember exactly what the histology is, but there's more and more cells. So the primary follicle is now called the secondary follicle, and stage 3 is the previous slide we just looked at. And there are cells that secrete hormones in response to LH. So I had mentioned earlier that there's those cells have a paracrine effect. If you recall back to the endocrine system, you learned that a paracrine affects a neighboring cell, kind of almost like a parallel cell. So it's like a hormone, but it just acts locally. The secondary follicle then is going to become a vesicular or antral follicle. And that secondary follicle ends when liquid accumulates between the granulosa cells, forming the early vesicular follicle. So the antrum is a large cavity that is formed when all the fluid coalesces and the antral phase begins. The secondary follicle then officially becomes the vesicular follicle. The isolated oocyte has cells called the corona radiata, the radiating crown, and it's ready to be ovulated. Now it's a secondary oocyte, and what remains after that is called the corpus luteum, which is what's going to produce those important hormones that are going to help to sustain that early on developing embryo.